Welcome to Study Loop.
We'll first calculate the energy density in the sunspot, and the energy density little u is equal to b squared over 2 mu naught, where b is the magnetic field strength. So we know the magnetic field strength is 0.4 Tesla, and that's squared, divided by 2 times the constant mu naught, which is 4 pi times 10 to the minus 7 in SI units. And hence we get the energy density, or the energy per unit volume in the sunspot, to be 6.366 times 10 to the power of 4, and that's joules per cubic meter. So now that we have the energy density, we can calculate the total energy of the sunspot. The total energy in a volume V is UV, and capital UV is equal to the energy density, little u, times the volume V. And we also know that this energy is all converted to kinetic energy. So K is equal to UV times this volume V, but the kinetic energy is given by a half m times the speed v squared. But we don't know the mass of the material. However, we know that the mass is equal to rho v. The density of the material times its volume. So this implies that a half times rho times the volume v times the speed v squared is equal to the energy density times the volume. And you can see the volumes cancel off. And hence, if we rearrange this equation, we can solve for the speed at which energy or material is ejected from the sunspot. And we can see from here that this is the square root of 2 UV divided by the density of material in the sunspot, which is given, rho. And hence, if we substitute our values in here, we get that the speed at which material is ejected from the sunspot is 2 times 10 to the 4 meters per second. And the speed that we calculate is about 30 times smaller than the escape speed from the sun.